Hello. This lesson will cover Lesson 1 for Basic Probability. This lesson will teach me to define probability, find the probability of a single event, and find the probability of mutually exclusive events. The definition of probability is that it is how likely something is to occur. Probability is the number of favorable outcomes or events over the number of possible outcomes or events. Probability is in essence a percent, or when it's written without being a percent, it's a number between 0 and 1. Think about something that has a 0% chance of happening, it's impossible, all the way up to a 100% chance of happening, it is absolutely certain, or a 50% chance of happening. So as we go down to 0, it's becoming less likely, and more to 1, it's becoming more likely. Mutually exclusive events are the events that cannot happen both at the same time. Look at my Venn diagram. If you notice, there's no overlap because these are two events that cannot both happen at the same time. The formula for mutually exclusive events has one of these symbols in it. So let me fill this out real quick. This first symbol represents the word and. This other symbol represents the word or. The way that I'm choosing to remember it is that this symbol kind of looks like an N, so it's and, the other one is or. So what this says is the probability of A or B is equal to the probability of event A added to the probability of event B. So here's my example of two mutually exclusive events. Think about a deck of cards. If you were to draw one card from a deck of cards, what's the chance that you were to get a king and a queen? Well, if you're drawing one card, that chance is 0. You couldn't both get a king and a queen. What about a king or a queen? Well, there are 4 kings in a deck of 52 cards, and there are 4 queens in the deck out of 52 cards. So that's 8 out of 52, which reduces to 2 over 13. So the probability of you choosing a king or a queen is the sum, or adding up, the probability of each event happening. All right, some examples. It says find the probability of each event. The probability of not a 1 when rolling a number cube. A number cube is just a dice, so how many options do we have? The total possible outcomes, there are 6. You could roll a 1, a 2, a 3, a 4, a 5, or a 6. The probability of rolling something that is not a 1 are all of these options, so there are 5 out of 6 chances. The probability of flipping both tails when flipping 2 coins. Well, thinking about our possibilities, you could flip 2 heads, a head and a tail, tails and heads, or 2 tails. So the probability of flipping both that have tails, well, there's 1 out of 4 chances. Some more examples. It says a bag contains 12 red marbles, 10 blue marbles, and 4 white marbles. 1 marble is drawn. Find the probability of each event. Well, 12 and 10 and 4 is 26 total possibilities. So the probability of you choosing a blue out of 26 is 10 out of 26, and then reducing that fraction. The probability of not blue would be your red and your white, so there would be 16 out of 26, which is the same as 8/13. The probability of blue or white, well, notice that you're only drawing 1 marble. So what we do, this is mutually exclusive. So we're going to take the probability of drawing a blue, which we already established is 10 out of 26, and add it to the probability of you drawing a white, which are these 4 down here, and we add them together, which reduces to 7 out of 13. Couple more. It says at a political rally, there are 20 Republicans, 13 Democrats, and 6 independents. If a person is selected at random, find the following. 20 Republicans, 13 Democrats, and 6 Republicans. Looks like it is 39. So the probability of selecting a Republican, well, there are 20 Republicans out of 39. If you want to, you're more than welcome to grab your calculator and find what that kind of percent is. it would equal 0.5, meaning 0.51, so about a 50% chance of selecting a Republican, a little bit higher. The probability of selecting somebody who is not an independent, well, the independents are these 6 down here, so that's 33 that are not independent over 39. So you can either simplify the fraction, which would be 11 over 13, or again, if you're interested to look at what the percent would be, it would be 0.85. So looking back at how certain that would be, because it's so close to 1, it is very likely that it would happen, which makes sense. That's 33 out of 39 people. The probability of selecting a Republican or an independent, and I do recommend you writing that word so you read it that way, otherwise symbols get very confusing. These are two mutually exclusive events. They're mutually exclusive events because if we select one person at random, I can't get a Republican or an independent. I can't get both of them. So let's find, or I can't choose a Republican and an independent. So now let's find the probability of or. So there are 39 people, and we said there were 20 Republicans. And the probability of getting an independent, those are the 6. So if I add all of that up, it's 26 over 39. That's a 3. It just got really messy. And then last of all, the probability of selecting a Republican or a Democrat, Democrat or an independent. Out of the 39 people, there are 13. We're going to add the probability of each of these events. So this ends up giving me 19 out of 39. So that's all the examples I have for you. Short video. Thanks so much. Let me know if you have any questions.